Hello, I wanted to go over some key properties of the trig functions as you guys are sorting through working with the unit circle. When we look at the unit circle and the trig values, what you're basically doing, and some of you probably learned it in high school as a wrapping function, but we don't use that term here, is we're actually looking for this distance s that we see on the curve given some angle theta. And what I want to do is basically take this arc and straighten it out into a length of t units and have t be represented by some point x and y. So when we do that with the trig functions and our unit circle of the radius being equal to 1, we get our ratios like cosine theta x over 1, sine theta y over 1, and tangent theta y over x. And then we're able to establish these values. Like when theta is 0 degrees, because you're sitting on the x-axis right here at the point 1, 0, the x value is 1, so the cosine is 1. The y value is 0, so the sine is 0. And then because tangent is y over x, then 0 over 1 would be 0. I think that the book gives you two sets of ratios, and as a student you don't want to have to learn a lot of different things, so it's easier to learn these ratios with the radius of r, so that for any circle you can determine any of these trig functions. And then if you're on the unit circle where r equals 1, it's as simple as plugging the 1 in here for r. So I learned these 6 so that I can find my trig values for any theta. When we look at a point, the biggest thing that you want to do is not take for granted that it is on the unit circle unless they tell you. So like in this case, this point is on the unit circle, so we can assume that r is 1. And I just remember the problem from class, so I apologize, but we give this point on the unit circle, and so then we're able to identify the values of our cosine functions. Notice what happens though, this point is actually in quadrant 2. So when I look at taking the cosine of that angle and I'm looking at x, x is a negative number. So for the cosine function, I get a negative answer. And because secant is the reciprocal of cosine, secant is also negative. And because tangent has a positive y over a negative x, then tangent and cotangent would both be negative. So the sign, S-I-G-N, of the quadrant, of where that angle lies, is very important for your values on your outputs. It's something that'll trip you up throughout the entire semester if you're not aware of it right now. And we don't have to just have thetas that are less than 360 or 2 pi. We can look at taking like the tangent of 8 pi, so that when I do this, I'm actually traveling the circle. I started here and went 2 pi, and then another 4, another 6, and then finally 8, and I get this final point where I'm sitting on the x-axis of 1, 0, so the tangent at 8 pi is also 0 because again, y over x. But like I said before, the signs of the trig functions are very, very crucial. And so you want to recognize where your x-axis is positive, where your y-axis is negative. And there is a trick where all students take calculus. All of my trig functions are positive in quadrant 1. In quadrant 2, students starts with s, where sine is the only positive trig function. And of course, it's reciprocal. So when we're talking about all, we're talking about sine, cosine, and tangent. The reciprocals are assumed. When I go to the third quadrant, take starts with t, where tangent is positive, and sine and cosine are both negative. And in the fourth quadrant, calculus starts with c, so cosine is my only positive because of the positive x-axis. You want to familiarize yourself with the special angles and how they work. You definitely want to get this unit circle down. The proof is actually very nice. If you take a look at this really quick one here, what I've done is I've created an equilateral triangle. And in geometry, that means that all of my angles are equal. So all of these angles are 60 degrees. And the radius is 1 because I'm on the unit circle. If it's an equilateral triangle, then we know that if all three angles are equal, then all three sides have the same length. So I use the x-axis as a bisector to create this 30-degree angle, and this height on this triangle leg right here would be 1/2, because again I bisected the 1. So when we talk about the coordinate for this point right here, I'm going over how far? Well, I know that the hypotenuse is 1, that this leg is 1/2. So by using Pythagorean theorem, we get the length of this leg to be the square root of 3 over 2. So my x-coordinate for this distance is radical 3 over 2. The y-coordinate, how high up did I go, is 1/2. So this creates the trig values for 30 degrees. So the sine of 30 degrees, 1/2. The cosine of 30 degrees, radical 3 over 2. These ratios are very important because basically what it says is that if I ever need to create a 30-degree angle, then the ratio of the side to the hypotenuse has to be 1/2. So if you're making steps and you know that this is going to be a 30-degree downslope, or if you're making a slope a ramp in order to bring things up, and this ramp needs to be 30 degrees, then you know that when you measure the height, it has to be 1/2, and that your hypotenuse has to be a length of 1, or some other ratio that would come down to 1/2. So it could be that you put 3 here and 6 on the hypotenuse, as long as that ratio is 1/2. That's what we're looking for when we have these trig values. And I just want to go through a couple really quick here. I don't want to make this too long so that I lose you, but it's some things like, if I have the cosine of 330 degrees, how would I determine what that value is? If you graph 330 degrees, it puts you into quadrant 4. This little guy here is called your reference angle. We label him theta prime. It's the distance from the x-axis to the terminal side, regardless of quadrant that you're in. The reference angle is the distance from the x-axis to the terminal side. In this case, it would be 30 degrees. 360 minus 330. I use the reference angle to determine my value. The cosine of 30 degrees is the square root of 3 over 2. I'm in quadrant 4. Is cosine positive or negative in quadrant 4? Because the x-axis is positive, cosine is positive. Therefore, your final answer, radical 3 over 2. And the more you do these, the better that you will get at doing them, because it is a technique that you will need until we're done with this class. Not just this chapter, not just chapter 3, the rest of the class. A big thing here, check your mode. When you're looking at radians versus degrees, you want to make sure that you check the mode when you figure out the problem for the answer. If you have problems where they're not telling you that you're on the unit circle, they just give you a point, you cannot assume that you're on the unit circle. The assumption is that you are not on a unit circle. So when they give you the point, you always want to make sure that you identify your R. Remember your Y value, X value, and then we want to find R. If it comes out that R equals 1, then that means that you were on the unit circle. But never assume that you are, because it will mess up these ratios as you work through them. And then here's some more stuff about the reference angle. Here's an example of 13 pi over 4. Where would I find that? Well, the best thing to do is do fractions. 13 divided by 4 is 3. And then you have 1 left over. So what you end up with is 3 pi. So here's 2 pi. And then here's 3 pi. And then I have pi over 4 left over. So I know that I'm in quadrant 3. Your reference angle, pi over 4. The distance from the x-axis to the terminal side. The other thing that students do is convert 13 pi over 4 to degrees and then graph it. But I think that you'll find that if you work with your fractions, it's a lot faster. So again, notice I said 3 pi units. So I went 3, here's 2 pi, here's 3 pi, and then I went pi over 4 and dropped down into quadrant 3. What this allows me with the reference angle is I was looking at cotangent. The cotangent of pi over 4 is equal to 1. Is cotangent positive or negative in quadrant 3? Well, I'd have a negative x over a negative y, which is a positive number. So our answer would be a positive 1. Your reference angle is always less than 90 degrees. If we do one more quick, the cosecant of 765 degrees. So when you plot 765, you find out that you end up in quadrant 1 and that your reference angle is 45 degrees. So you want to find the cosecant of 45, which is radical 2. Identify if cosecant is positive or negative in quadrant 1, which it's positive, and then that gives you your final answer. The sine of 7 pi over 6. Okay, well, 7 pi over 6. 6 goes into 7 once. That leaves me 1 pi, and then I'd have pi over 6 left over. So I'm going to go 1 pi, pi over 6 left over. Drops me into quadrant 3 with a reference angle of pi over 6. Because all you're doing is taking 7 pi over 6 minus pi to figure out that reference angle. The sine of pi over 6 is 1/2. Is sine positive or negative in quadrant 3? It's negative because y is negative. Therefore, your answer is a negative 1/2. And then here I've just drawn out the unit circle and the table. And you can do either one, but I think you'll find that the unit circle is a lot easier to work with. It's very important that you learn this. Again, when you take your proctored exam, you will not get this. You will not be able to have the unit circle. When you take the final, you will not be able to have the unit circle. So you want to make sure that you have this known in your head. Notice the relationship between the radicals. If I start out at 0 and take the square root of 0 over 2, I get 0. The square root of 1 over 2 is 1/2. Here I have radical 2 over 2. Here I have radical 3 over 2. The square root of 4 over 2 is 1. And you can do it the other way also. Start at the 0. This you should know because your radius is 1, so this point here would be 0, 1. So square root of 0 over 2. Radical 1 over 2. Radical 2 over 2. Radical 3 over 2. Radical 4 over 2 is 1. So I hope that this quick look has helped. And as always, if you have any questions, please don't hesitate to contact me.